On this week's NFV SDN Reality Check, we'll look at some of the top news items from across the space, as well as speak with Quortus to get a primer on mobile edge computing. Well, thanks for joining us on this week's NFV SDN Reality Check. I'm your host, Dan Meyer, Editor-in-Chief at RCR Wireless News. On today's show, we have an interview with Riki Dolby, who's the Director of Engineering at Quortus, to get a primer on mobile edge computing. But first, let's take a look at some of the top headlines from across the telecom-related NFV, SDN, cloud, and software space in the past week. Well, I recently had a chance to attend the Open Networking Summit in Santa Clara, California, where the obvious topic of the event was on the use of open source technology by telecom operators as they move forward with their software deployments using SDN, NFV, and cloud technology. During a keynote panel, AT&T's Chris Rice said the open source community was maturing enough to make it possible for the telecom giant to rely more on such platforms in support of its push into software control of its network. Rice explained the carrier had about 100 developers working in the open daylight area, sponsored academic research, and was working internally on its network, cloud, and automation platform. Rice also touted the carrier's recently launched ecom project, which was at 8 million lines of code and growing. Brocade's Michael Bushong said from a vendor perspective, the move towards open source was a big change, and that instead of focusing on making your stuff sticky, it's now how to make yourself easy to replace. Bushong said that was a tough business model to sell to executives, but that's where the market was heading, and it requires a new way to look at the business. Bushong added it also disrupts incumbency and forces vendors to compete on a best of breed, which he said was good for competition. Accenture's Gene Resnick said software was a way for telecom operators to further differentiate their services from both their traditional competitors and over-the-top players. In addition, Resnick built on Bushong's comment in noting the economics of software are very different when compared with hardware, made even more so when dealing with open source software. Focusing on the workforce challenges, Jim Zinlin, who's the executive director at the Linux Foundation, said the move towards open source software is forcing the industry to re-examine its employment needs. Zinlin explained companies can use open source software to leverage their employment needs in what he called a people game, adding developers matter in the process. Also this week, CenturyLink announced plans to increase capacity at 4 data centers through the first half of this year. The telecom operator said expansion plans were based on a growing demand for flexible hybrid IT capabilities, such as co-location and cloud consumption, and build on its move last year to add 14 megawatts of capacity at 8 data centers. CenturyLink claims it has completed 39 data center expansion projects over the past 5 years, including the addition of 11 new data centers. The company said it currently offers more than 2.6 million square feet of gross raised floor space throughout North America, Europe, and Asia Pacific. CenturyLink last year announced it was looking at strategic alternatives for its data center and co-location business operations, in a move analysts noted could include further breaking apart of CenturyLink's operations. The company said at the time it was looking at a full range of options, including a partnership or joint venture, or the sale of all or a portion of its data centers. During the company's most recent quarterly results conference call in early February, CenturyLink management said it was still moving through the process. Well, all right, that'll do it for this week's news. This week's featured interview, we spoke with Riki Dolby, who's the Director of Engineering at Quortus, to get a primer on mobile edge computing. Let's take a look at that interview now. Well, thanks for joining us this week. My name is Dan Meyer, Editor-in-Chief at RCR, and this week we are joined by Riki Dolby, who's the Director of Engineering at Quortus, and we're going to talk a bit about the mobile edge computing space, something for myself. It's pretty new to me, so hoping to get some great insight from Riki on this topic. Hey, Riki, thanks for joining us this week. We appreciate it.
No problem. Thank you.
Great. Let me start off with, for those who don't know much about Quortus, maybe give a little overview of the company, just kind of kick off the conversation.
Yeah, sure. So Quortus is a software company. We provide 2G, 3G, and 4G core network software that target a variety of different markets. But we're not trying to compete with the likes of Ericsson. So we focus on differentiating our product through enabling innovative and beneficial network architectures, including pushing some of those network functions, or sometimes even all of those network functions, to the logical edge of the network. One example of that is we can provide scaled down, completely collapsed solutions that have a really small footprint, and you can run a complete mobile core network on an embedded processor. A few years ago, we did a really cool demonstration where we ran a complete 4G network on a Raspberry Pi. Not something we'd sell, but it's a good point. So one of the other things we can do with that is put our software on the same SoC as the radio baseband processing inside a radio. So what you can do there is turn a single radio into a complete mobile network. And we target those sorts of applications at military and public safety customers. So that, the ability to put cellular comms in a vehicle or a backpack and just go with it, go wherever you need to. And we've got some really cool extra features with that, like meshing and some multicast enabling, so that network in a box or bring your own coverage or bring your own capacity solutions works seamlessly for those sort of customers. The other area that we can provide, we scale up as well. So we're not just little tiny systems inside a chip. We scale up and we work with MNOs and MVNOs. And again, in these sort of markets, our customers are looking for novel solutions that allow them to build something that's quite fundamentally different from a stock product offering that you might be able to deliver with kit you buy from a tier one vendor. So something different for us. And the particular specialisms there for us are things like the M2M, the machine-to-machine space, enterprise usage, and some global roaming services. So we've got customers in those sorts of spaces that love what we can offer there. And then particularly relevant to this sort of discussion, the final area is we target the enterprise and rural markets with product offering that is specifically designed to target easy deployment of in-building and remote solutions. So that you can integrate the cellular world with local PBX or LAN services. An example of that might be deployment in a healthcare situation. So you've got cellular in the hospital, and it's sort of more isolated and more resilient than if it was dependent on a cell tower stuck on top of the building. But also, if you push further still, like an oil rig or a maritime deployment, where you can have a complete network deployment, cellular system, but the backhaul satellite. So it's much more important to have more and more of that clever functionality actually on the remote site and integrating in with all the services that are normally there. You turn up with your own handset, your standard SIM, and you just fully integrate with the VoIP PBX. In most of the cases in those sorts of deployments, we tend to work through system integrators rather than directly targeting those customers ourselves. And that's really cool because they bring all sorts of extra skills and extra product into the wider solution. And we've got customers who've done presence services, Outlook integration, local alerting things. So somebody raises an alarm or on a handset. If you've got special handsets, then nearby users get told about it. Maybe auto answer a conference call, and you get a whole bunch of really cool over the top community services, and that's all on top of simple voice and data services, which you'd get with a normal cellular network.
It sounds like a very scalable solution. Obviously, you're able to go to, almost the smallest of deployments, really up to, like you said, MVNOs and MNOs out there. So, the scalability seems pretty impressive by this. I'm guessing because you guys are so entrenched in the software side of things, I'm guessing the software is a big part of that scalability aspect of all this. Yeah, so it's designed. It was designed from the start to be scalably down, and then we've grown up with some. As I said, we're not trying to compete with the likes of Ericsson or Huawei. So if you want, 100 million users, go somewhere else. But anywhere between 16 users and 10,000 or even 100,000 is the sort of comfort zone for us, where it's not economic for the big boys to play, and we can make it extremely viable to make that one-to-one relationship between a radio and the core network, which is that's quite unusual to be able to do that. Sure. Yeah. I guess, is the technology itself, is it scalable to a much grander scale, or is it just a matter of, the fact that for you guys, obviously, it might not make sense, try to compete with those bigger guys. Do you see the technology itself being scalable? Could someone like an Ericsson or a Huawei, could they take something like this, at least the basis of this, and use it in their own, platforms and roll it out to operators, do you think? Or do you think this is more of a, perhaps a more targeted and more specific type of technology that perhaps won't play quite as well in these large deployments? I think sort of in the wider space, the challenges are
if you take the likes of those tier one vendors, they've gone through the specifications, and they have invested thousands of man years of engineering effort to tick every single box.
Okay.
And so in one sort of perspective, they've got a whole bunch of functionality that our customers don't want and won't pay for.
Sure.
And at the other side, they couldn't produce a scaled down solution. So clearly there is some compromise. If you've got something that is capable of doing 16 users and running on a Raspberry Pi, it's not the best platform for doing 10 million users. It can scale up big, but it's best in that sort of low to mid tier. That's our focus, and also because those are the customers that have the most innovation, and so they're the ones who are really looking for ways to differentiate from everybody else, and that's where we can add value as well, because we love hearing what customers want and bending our software into slightly unusual shapes for them.
That's a good point. It does seem like those segments that you guys are targeting are pretty hotly or growing rapidly as well. I mean, obviously we do a lot on this show talking with kind of the larger vendors and some of the carriers about their NFV and SDN plans. And a lot of these initial deployments are targeting a lot of those same segments, perhaps at a bigger scale than what you guys are doing. But still, those segments are the ones that they're seeing as being their initial targets, because it does seem like those are segments that want this and they're kind of ready to go with it now. I mean, they're not a lot of hangups there, and they've got something a little more segregated from the traditional wide area networks too. So they're able to go. It seems like that's kind of a big segment for this right now.
No, absolutely.
Yeah. Very interesting. No, I guess again, we do a lot with kind of the broader NFV and SDN space, and there seems like there has been a lot of development in terms of those technologies for telecom. I mean, have you guys seen a lot of crossover between what's happening from those bigger tier guys, those bigger vendors, and the carriers themselves with what you're doing also in terms of kind of your software-based platform out there?
Yeah, I mean, to a certain extent, we're sort of feeling a little bit smug in the sense that finally the rest of the world has caught up with what Quortus has been doing for years. Is that our software, our solutions have always been software. Yeah. We running on VMs since we started. If you take that key elements of all the core network functions and just say it's software, where would you like to deploy it? The architectures that we've been working with customers to deploy and installing in all sorts of places, it's SDN, NFV. That's now what everybody else is doing. And, that's fine. We can be smug.
Yeah, I understand. I mean, that's definitely understandable, because it does seem like a lot of companies have been. I mean, we've seen a lot of people like from the data center space who've been using this technology as well in the past, and again, they're starting to kind of dabble in the telecom side of things. And talking to them, they're very comfortable with this technology. They've been using it for years and years. They are, I don't want to say smug, but they do say, hey, this is our bread and butter. We're used to this. Where to some of the larger vendors from the telecom side of things, and to them, they're definitely taking a more slow and gradual approach, and that could be because they have just certain business models in place too, which might not scale to these types of things. But it does seem like, at least from the carrier side, the telecom operator side of things, they're looking for companies that have experience in the space to come and help them out. And I'm guessing for you guys, I mean, again, that does help, provide at least some validation to what you've been doing. But it seems like it could also provide some great opportunities to even migrate further into the telecom world, into some of these operators, because again, they are looking. It seems like they're pulling for some help on this and trying to get some pretty rapid deployments as well.
Yeah, and that's particularly the case when we talk about the mobile edge computing space, where in order to do things there, the leveraging all of that NFV and SDN mindset makes that a lot more possible, a lot easier. If you've already signed up to COTS hardware and SDN and NFV as a concept in your network deployments, then building in an extra capability like mobile edge computing, that just sort of drops into place then.
Yeah, I guess as operators look towards running towards mobile edge computing as part of their overall software strategy, I mean, what sort of efficiencies can they see from what you guys have seen in your own networks, your own deployments? I mean, what sort of efficiency can they get out there? I mean, is it a significant advantage? Is it something that kind of takes some time? Or I guess how is their efficiencies gained in the network, and over what kind of time frame are they seeing these sort of efficiencies?
Well, the sort of that side of things is related to the primary benefits of SDN and NFV in the first place. So, originally SDN and NFV were all about breaking away from the dependency on the custom hardware.
Mm-hmm.
So if you went to Ericsson or Nokia or whoever, you'd buy racks of 19-inch equipment that were specialized to the purposes that the telco functions needed.
Yeah.
And the ability to move to cost-effective solutions built on COTS computing platforms that scale easily and dynamically is what it was all about.
Mm-hmm.
And we can talk about how that relates to mobile edge computing, but in the general terms, it's mostly about enabling those large vendors to deliver functionality to operators that the operators aren't going to worry about having the hardware go out of end of life 2 years after you bought it. Mm-hmm. And the fact that every new software upgrade might need new hardware upgrades, that the decoupling of that is the critical driver for NFV in the big network space, I think. In terms of performance, arguably custom hardware is going to give you better performance. The trick is to get good enough performance out of COTS hardware, but it scales so much more easily that buying another blade server, it's nothing compared to an ATCA blade in a custom platform chassis or something. It could be a nightmare in costs in those sort of cost terms.
Yeah. That's something I've heard a lot from the operators too. Is that they are trying to find, I guess, that crossover point between obviously legacy equipment, like you're saying, can perform better, but there's also the cost issues there involved, and the scalability and the future proofing of the network as well. And that's kind of where the software side of things, or the NFV and SDN side, comes across. Yeah, it does seem like they're trying to kind of reach that crossover point to where it makes more sense for them on their networks to do this. And obviously, some operators have been more aggressive in that and been very, very vocal about what their plans are, and have set dates and timeframes and things like that. Where others are definitely kind of taking a more of a slower approach. But it seems like to you guys, at least, that the scalability and the robustness, I guess, of a software platform can serve what the telecom community needs, whether it's whether you want to call it carrier grade or 5 nines or whatever you want to call it down the road. From your point of view, from what you've seen, at least with your solutions, software can supply that.
Yeah, and yes, absolutely. And I think there's a couple of points to say to that. One is, the IT world have been delivering resilient solutions. People have been running Microsoft servers and Exchange servers in clustered IT environments with SANs and geo resilient architectures for a long time. So to a certain extent, it was I hesitate to use the word arrogance, but it was an arrogance on the telco world to say, we do it better because we do it on this custom hardware. And actually all the IT guys are going, well, we solved almost all of those problems without having to go to the custom hardware. What's wrong with you? Yeah. The other thing that I think is important and is again where our positioning comes into play is that we're finding, and when we engage with our customers, there are a very large suite of the customer base who don't want or need the same telco resilience that we've been used to. So if you're running 10 million customers, or a network of that size, clearly, if a network element goes down, you need it to have a hot standby and fail over instantly, and nobody notices. But actually, both in the mobile world, how many times have you driven down the road making a phone call in your car and the call drops? It's not perfect already. And when you're talking about some of the smaller deployments, like we engage with, where if you're on an oil rig, we only need to be as good as the enterprise infrastructure anyway. And in those cases, customers don't want to pay for 5 nines resilience because they don't need it. And so again, one of our differentiators is, yes, we have a resilient solution and it's absolutely good enough for what our customers need, but you're not paying the premium for a whole set of functionality that you don't need. And that opens up a suite of customers who are looking to deliver things and services that as cost effectively and as usefully as possible.
Yeah, and that seems to kind of reserve a good market segment for you guys because, I mean, for us, I would find it hard to see how like an AT&T here in the U.S., AT&T or Verizon or Telefonica or Vodafone or somebody would want to go to a company and say, hey, our service might not be perfect. I mean, because that's kind of what they always, they never want to push that their network quality is not 100%. Obviously, we all know it's not, but they're never going to say that. So it seems like for a company like yourselves or other vendors out there who do come from the software side of things, yeah, I mean, your ability to go to an enterprise or to a rural carrier or something and say, hey, this is what we can offer. It's you're never going to notice the difference between it. That seems like you guys have a segment out there that is kind of ripe for you guys to really go out there and take quite a bit of business out there. It seems.
Yeah, the tier 2 and tier 3 MNOs, a whole bunch of really innovative, hungry MVNOs who are going, hey, we can offer those sort of global services. We can offer services to those remote verticals, so mining sites, oil rigs, those sorts of things. People in international waters, the airline industry. It's a whole suite of places where the MNOs who own the licensed spectrum haven't got the same control, but the customers want a solution, and it's not at the scale or the levels of resilience that you'd expect or want to pay for in a big inland macro network.
Yeah, it's a match made in heaven for you guys out there. So
yeah, absolutely,
very good. Yeah, exactly. Well, so maybe let's go back to you're kind of touching a bit on how MEC kind of plays in the mobile telecom space and kind of how that's been advancing. I mean, obviously, like you're saying, I mean, the mobile space, we all know it's growing a lot, and there's a lot more, pressure being put on those networks out there, I mean, the data traffic and things like that. And again, being able to use more software out there to make it more scalable, more agile seems like a great way to go. And it seems like, again, my knowledge is not as deep, obviously, as yours, but in the MEC, how MEC relates to that, it seems like it's a great way to kind of advance these mobile telecom networks in a pretty cost-efficient way too.
Yeah, I mean, maybe if we sort of talk a little bit about where MEC has come from and where we think it should be going to and where we want it to go to. So, I mean, traditionally, in the early sort of vision of MEC, it was about taking cloud computing and IT services in an environment at the edge of the cellular network. So sticking those sorts of functions in and around the cellular base station. That was really useful because you've got, when you combine it with the cloud computing model, you've got rapid agile service delivery. You can configure it easily. It's all software defined. From a cellular perspective or from a sort of user experience, it's low latency because it's right at the edge of the network. You're delivering those services locally. It's, as you're saying, low stress on the core network, because if you can get service or content out to the edge, then you can manage those users, you can deliver those services, but you're not loading up the core of your network just because for some reason somebody said all data traffic from a mobile network has to route all the way through to the central PGW. And if I'm trying to deliver, if I want to watch a film, if I can get that film content close to the radio and deliver it, well, it's not to like. And it's also, to a certain extent, about trying to get the IT and internet world who are arguably running the over-the-top battle with the MNOs into a place where it's cooperative rather than competitive. So we believe, and I think the MEC community generally believes, that if you can get those internet and IT mindset service providers to deliver something that works in partnership with the cellular network, then you can get extra information about the user, where they are, whether they're getting a good quality of service, be that looking at big data things like video analytics. So I can see that you're struggling to watch this video, so I'm going to change the codec for you. Compared to, as I say, getting the content out to the edge of the network. Now, in the early days of MEC, and to a certain extent it still is, that was sort of seen as independent from the cellular world. So it was sort of bump in the wire. So you put a piece of functionality sort of co-located or near the radio, so maybe in the customer premises, adjacent to the radio or set of radios in building. And you interfere with the signaling traffic or the data, the user plane, you monitor the signaling and you interfere with the user plane in order to do these sort of breakout and analytics services. Now, we're not particularly convinced that that's a good idea, because that then there's a whole bunch of things you can't do. Now, the key example of that is if you are not part of the mobile core network, if handsets goes to idle, and I've got a push service. Let's say I'm in enterprise and I'm doing in-building, I've linked into my enterprise mail server, and I want push mail delivery via that local service. If the handset's gone to idle and I'm not part of the mobile core network, I can't page it to get it back again. So the Quortus solution and the architecture that we're proposing is all about having the functions that are in the customer premises being part of the core network. And we can talk a little bit more about that in a minute, but they're leveraging all the SDN mindset. So the user plane processing is in the customer premises, but you've got all the core network functions, all the important bits that operators like to control, and for regulatory and legal reasons they need to control. So you've got billing, you've got the perennial problem of how do you do legal intercept when you've got things on the customer premises. But you know, all that control is at the core, but you've still got the ability to deliver those local services with low latency and all the other benefits of it. So you can get those converged services, which you wouldn't be able to otherwise. So sort of arguably our picture of this is about having intelligence in the network and over the top of the network. So you can't just sort of degrade the view of the MNO to being a bit carrier, a pipe provider. There's more to it than that. They need to be involved. They need to have a bigger play than that. And actually, if the likes of the content providers, be that Facebook, Google, Netflix, whoever, and the mobile operators can actually work together, everybody will win better, and be able to provide better services that way. So as I say, our sort of picture of this is getting the primary telecom processing elements inside the MEC device. So user plane processing for actually the SGW. That's the architecture that we're saying. So most of the rest of the network, you don't touch it. The MME, still the core network's MME, core network PGW, but the SGW does some user plane processing in building, and you have the control plane element as an aggregator in the core of the network, or in the cloud, effectively. And that allows you to solve all those problems with billing, legal intercept, and management interfaces, because they're all set centrally. And what's really cool about this is we've got some good traction with that. So one of the things we're doing in Barcelona is demonstrating this on the Intel stand with our system integrator partner ACS, and they bring the management suite. So the ability to take all of that orchestration from NFV and from the sort of thousands of remote management problem. I've got thousands of remote devices. I need to manage them. I need to bring them up and down. I need to know when they're going. That's where the system integrator comes in, and they've got a really, really cool offering for that. And we push the telco piece out in the right way and distribute it across those customer premises and have that central element. And what's fun for us, of course, is that it's not really any different from what we've been doing for several years. We've got hundreds of enterprise deployments and remote deployments that take our what we call ECX, our edge-centric technology, and just enable these integrated services. All that's happened is that we sort of tweaked the architecture and given it a different name. But if that...
Don't sell yourself short like that, come on.
Well, no, in terms of MEC, that's the only real difference from what we've been doing before. And what we've been doing before is solving these problems anyway. And there's a little bit of architecture change, but actually it's a really powerful change that enables all those things in a way that's very MNO friendly. And that's one of the most important things about what we're proposing for the way MEC should look.
Does it sound like then, I guess these things that you're proposing for MEC, is it getting quite a bit of acceptance, you think, from both the vendors and I guess from the telecom operators, or a lot of them are actually driving a lot of this?
Yeah, I mean it's early days in the MEC world. They're still, so the Etsy group are still looking at use cases, at the whys and wherefores, and as is quite often the case with small nimble companies, you tend to get ahead of the standards and then go along and say, well, it works, so you want to do it this way. But we are by working with those sort of big players. There are some very interested big MNOs, as well as as I say, partners like Intel. It's they're key players. I mean, Intel, among others, were the sort of founder members of the Etsy MEC group. So you've got a lot of telecoms big players there. Nokia, NTT Docomo, Huawei, Vodafone. They were all in there at the beginning, saying this is a good thing. We know we need to offer something that solves problems in this sort of way.
Mm-hmm.
And so what we're doing with that sort of route is to say, the original view of that bump in the wire, that it's not part of the mobile network, is probably, being brutal, unviable. So if you do what we're suggesting and can demonstrate and are demonstrating, then you get something that's easy to integrate and yet gives you all of the benefits of the original vision of MEC.
Yeah, makes sense. Is there a limit to how far software can go in these networks? 'Cause, I mean, it sounded like earlier you're saying, I mean, you guys have kind of used software for, quite a bit of your deployments and working with your customers. I mean, obviously in the larger networks, at some point you have to have an antenna somewhere out there, but and probably some fiber going somewhere as well. But it seems like, from what it sounds like you're saying, I mean, you could really use software, at some endpoint to control a pretty significant portion of a mobile network, really.
Yeah, absolutely. I mean, there are some really interesting applications where we've got customers, unusual customers who have, so non-commercial customers who have spectrum of their own, and they're looking to provide secure mobile networks in building. And they're going to be an MVNO of a macro network, so that they can have roaming out capability. So if they wander out of the building, they can get coverage and use the macro network. But the in-building stuff, the whole network is being provided by the solutions that we're providing. And yeah, absolutely, they buy they buy radios, whether that's a big radio plugged into a DAS or a bunch of small cells, and they scatter them wherever they need to be. There's no real limit to that.
Uh-huh.
It is just a case of sort of almost functionally partitioning the network. You've got high numbers of highly mobile users in the macro network. So there's clearly a solution appropriate for that, which is lots of radios and big scaled up solutions. And then in the enterprise and the in-building side of things, because you need that closer relationship to the services that are hosted locally or actually integrated into the enterprise, then the solution scales differently.
Mm-hmm.
In the early days of Quortus, we used to say that we sign up to the internet philosophy of scaling.
Mm-hmm.
If somebody builds a new house and they want to connect to the internet, they don't have to add new capacity to a big core router in a data center somewhere. They just buy a box and plug it into their broadband at home. And the internet scales by lots and lots of small devices at the edge of the network.
Mm-hmm.
And that's our philosophy, is that by pushing functionality out to the edge, you actually scale much more easily and provide better quality of experience.
Yeah, makes sense. Well, yeah, we can probably talk on this for a lot longer, but maybe one wrap up final question on this would be, I guess as you look forward a little bit, I mean, what are maybe the one or two big challenges you see in terms of the continued evolution and adoption, I guess, of MEC in the mobile telecom space at this point?
So, I mean, MEC is forward-looking in its own right. So that's one thing we're saying, is that there's a lot of the best bits of the 5G architecture ideas that are being talked around fits into the MEC world in its own right. So that's really positive. You've got there's the concept of network slicing, the ability to drop out data at all sorts of different places in the network. But you can deliver that with mobile edge computing with 4G networks and standard 4G handsets now. Mm-hmm. So that's really powerful. But it's about, as you say, that the challenges there. I think there are a couple of them. Fundamentally, one is technical, and I think that's to do with scaling the NFV and SDN mindset beyond what would be how it's currently used. So if you take a core network element like an MME, for example, if you're building a pool of MMEs, you might have a handful of elements that you've virtualized and run on, a set of cluster hardware. When we talk about mobile edge computing done properly, you've got thousands and thousands of those network edge devices that are all party to the same management problem and the integration. So we've got to find some technical solutions to that. But actually, that's okay, because as an industry, as the telecom industry, we spent a lot of time and effort solving those sorts of problems. The small cell deployment, efforts that have gone on with managing and deploying those, it's exactly the same problem. So that's cool. And we already have nodes that do some of the aggregation functions. So the Home Node B gateway, it's a great way of bringing together and managing the fan-in of lots and lots of small radios so that we can talk to the MME in a sensible manner. And again, with the Quortus architecture, actually the SGW control plane element acts as the aggregator for all the data services, all the user plane functions, and all the other networking signaling components that might sit out and about in the edge of the network. So that's pretty cool. The business challenge, the other sort of really difficult one here, is more about the ecosystem. So that there are lots of stakeholders involved in trying to engage with delivering these services to enterprises and those sort of in-building solutions. And it's difficult because the MNO owns the spectrum and they know how to engage with users, but it's the enterprise IT management and those enterprise IT service providers who know how to talk to businesses. And traditionally, MNOs aren't very good at talking to businesses. And especially when you compare them with the likes of the IT specialists, Cisco, HPE, Microsoft, they have found ways of enabling channels who are full of highly skilled partners who know how to do stuff on the ground, do the installation, commissioning, consultancy. If I'm doing a small cell install in a building for a big business, it's not going to be an MNO who's going to know how to install 50 small cells in a large office without winding up the IT manager, because you've got to get power, you've got to get network, you've got to talk all the right languages. And so finding a way to get the MNOs to offer a service that the enterprise wants and is willing to pay more for. Because one of the things we haven't said is that a lot of the MEC side of things from the MNO perspective is about solving an in-building coverage problem. And if I'm a business user or an enterprise IT manager, I want my in-building coverage solved, but I don't want to pay for it. And I certainly don't want to tie myself to an MNO just for the pleasure of having them solve it for me. So we have to offer as a cellular world something that the enterprise guys want. It's got to be good for the MNO. It's got to be good for the enterprise IT manager. It's got to be good for the end user. And in the mobile edge computing perspective, it's got to be good for those IT and internet service application providers, so that everybody is motivated to pull it together and deliver something that makes more money and keeps the customers happy. And that is going to be an interesting challenge. I think with the power of the cellular spectrum, the proper quality of service management, and the seamless mobility in and out of the building that the cellular world can offer, I think when you combine that with integrated local IT systems and applications delivered close to the network edge, close to the user, I think there's a really compelling story there. And I, for one, really look forward to seeing the MNOs work with channel partners to deliver that vision, because we all want to benefit from that. And I think that's the future that MEC talks to really strongly. So.
Yeah. Well, obviously, that seemed like that technical issue that you brought up initially. That's something that smart people will figure that out. That's not a big deal. But you're right. That second part of it, the business side of thing, that will be the bigger challenge. I agree with you on that, and that will be, at least from a media perspective, much funner to watch, because that'll be a much more compelling back and forth on that one, I'm sure. Because that will probably take a while to get everybody lined up on that one. But again, you're right. I mean, at the end of the day, that stuff has to get solved because it'll benefit the carriers, the enterprises, everybody out there gets. There's benefit for everyone involved. So
I mean, those MNO. Those MNOs know, we see them being interested in this.
Yeah.
We know that the enterprise customers are the ones that have, they're the high revenue customers. They're the ones they really need to keep, the ones you want to keep sticky, the ones you want to win over from the competition. And so it's in everybody's interest to make it happen. And they're also the ones that want those extra services. If I'm at home, I just want to be able to make a phone call. But if I'm in the building, it'd be really nice if my mobile phone integrated with my PBX system in a way that meant that it was even more useful as a business tool than it is now.
Yeah, makes sense. Well, hey, again, Rick, this is again a topic we could probably talk on for another couple hours, but I will save your voice and my voice at all from doing that. And but again, hey, definitely appreciate the great insight. And again, as this all evolves and kind of again, we're covering a lot of this on this side as well. As we kind of keep going with this, we'll make sure we touch base with you again and perhaps even get an update from you here down the road as well on the topic. But again, definitely appreciate the great insight today on this. Thanks so much for the time today, and hopefully we'll talk again soon. Well, thanks for joining us on this week's NFV SDN Reality Check. Make sure to check us out again next week when we'll have more news from the across the telecom space, as well as our scheduled speak with PlumGrid on the deployment opportunities and challenges in OpenStack, SDN, and NFV. Thanks for watching.
NFV SDN Reality Check with Dan Meyer is a production of RCR TV. To suggest show topics or to reach Dan, you can find him on email, dmeyer@rcrwireless.com, and on Twitter @Meyer_Dan. For more Dan, news on NFV SDN and everything wireless, find your way over to rcrwireless.com.